Okay, this last video here for similar triangles, well, who knows, it might not be my last video. If anybody else has any application questions they want me to do, I could do them up for you. But so, the hardest one, I think, is the line of sight similar triangle application questions. Here's an example. Ryan stands 20 meters from a building. He holds a 10 centimeter tall pencil away from his eye, so it is exactly covering the building, top to top and bottom to bottom. If the pencil is 35 centimeters from his eye, how tall is the building? Okay, here's what's going on. So, Ryan is 35 meters from this building. Now, what he's doing is he's holding something up to his eye so that he's blocking this out. So what I'm going to do first of all is I'm just going to draw an eyeball here. I'm going to try to make it... Okay, so there's an eyeball. Now, what's going on is the light is coming... Well, think about it. Coming from the building to your eye, because the light comes in from your eye. Your eye does not shoot out light beams. It's coming from this building. So we'll draw a building here. And I don't know how far away this building is, but he's holding out a pencil so that whoosh, he sees just over top and just to the bottom of this pencil. So the pencil might be, say, there. That's what's going on. So he is looking just over top of the pencil, so he sees just the top of the building, or blocks it out, just blocks it out, just blocks out the bottom. So this is why it's a line of sight, because this pencil is using his lines of sight to the top and the bottom to get two triangles here. Now, let's measure these triangles. So this distance is 20. This distance from his eye to the pencil is 35. Now, you don't have to really switch here because the centimeters are going to divide out anyways, but it's always good practice to change it into the same unit. So if we're working in meters here, use 0.35. Now, this pencil is how tall? This pencil is 10, or 0.1. And the building is how tall? Well, it's x. So what's going on here? Well, we've got two different triangles. We have this triangle, and we have this triangle. Okay, so technically what we have measured here is we have the heights of these triangles. Those are the 10s, but the ratios still work out the same way. We can still take x and put it over its corresponding, which is 0.1, and that will be equal to, okay, we're going big over small, so 20 over its corresponding, which is 0.35. Now, cross multiply, pause and calculate, and x is equal to 5.7 meters. So, this is a little bit complicated, but remember that what you're getting here is you're getting two triangles again. So your big triangle is seeing over the pencil to the building. The big triangle is from your eye all the way to the building. And the little triangle is just from your eye to the pencil. So here, this was 0.35 away, this is 0.1, this is x, the height, and this is 20. So you are using this measurement right down the middle here. But it's still going to work for similar triangles because the ratios still hold. So therefore, the building is 5.7 meters. Okay, I'm going to do one more quick question because this can be done a little differently. So this time, Ryan puts his head on the ground and his friend Jenny moves a 3-foot tall stick until it just blocks out the building. Now, if Ryan is 20 feet from the building and the stick is 15 feet from the building, how tall is the building? Okay, so this time, it's pretty much the same thing, except, well, you have flat ground here. So you have flat ground, and you have a building, and here you have Ryan's eye is on the ground because he put his head there, or because he removed his eye, which is disgusting. Oh no, he put his head there. Okay, they explained that. Good. So he's very close to the ground. It's negligible. We'll ignore the height of his eye. He's going to look up to the building, and she is going to move this 3-meter stick until plunk. Plunks it right there. So now it is blocking out the height of the building, but same thing happens here. Here we've got right angles, so creating that similar triangle. Now, what happens? Well, put your numbers down. How tall is the building? X. Stick, 3 feet. 3. Ryan is 20 from the building, so plunk 20. And stick is 15 from the building, so 15 is in there. Now remember, we never use trapezoids, we use triangles. So, what's the little triangle? 3 and 5. Good subtraction. Cool? Big triangle, X and 20. So that 15 is really just there to get us the 5, and now we solve. So X over 3 equals 20 over 5. Cross multiply. I should be able to do this in my head. That goes to 60. 60 divided by 5 is 12. Therefore, this building should be spelled with an L. And now my L covers my I. Oh my gosh. Building is 12 meters tall. Alright, so there's 2 examples of similar triangles, line of sight. So what you do is you take an object and you just block out the line of sight to the other object, and you can use similar triangles. This is where you get small triangle inside big triangle. If you need help on that, go back to the video I did on that, on how to solve them. Cool. Good luck.